All right, so for the warm up, you were supposed to look at the dot plots, look at what's written next to the dot plots. What are some things that we noticed? Allison. So on one of the dot plots, the only answer was 10. Sorry, just trying to summarize. So that could be something you noticed. Anything else we noticed? Amari. They are all symmetrical. Ryan, anything? That was what it was. Anyone else have their hand up? Shannon?
The mean is the same.
Mean is the same for all. Yes. No. We'll discuss when we get to the side. But I tell you guys almost every day when the notes. But it's next week on Wednesday. But hold on, we'll get to that. Anything else we noticed from the dot plots? All right, so let's see. Yes. Good, so minimum and maximum the same for all. I didn't notice that. Well, actually, I guess that's except for one. Minimum and max is the same for almost all. All right, now let's look at, or let's discuss some of the things that are sample responses. So some other things that people notice. And that is some of the things that you could have noticed is that the MAD and standard deviation were both large for the same dot plots and small for the same dot plots. So I don't know if you guys read that little bit or noticed that little bit, but like here's the MAD, the MAD, the mean absolute deviation for all of them. What type of measure is the MAD? Is it a measure of center or spread? So phones away, headphones away. If you don't listen to me, I will send you to Janelle. I need that. I have to ask you one. All right, but back to this question. What type of measure is the mean absolute deviation? Is it a measure of center, like a typical value? Or is it a measure of spread, like how far away the value is? A measure of spread. So like which one is the most spread out? Which dot plot? Describe it to me, maybe tell me what MAD it has. Which one is the most spread out? Actually, this one is the most spread out, but that's a good guess. These two are the most spread out. This one's a little more spread out, and I can tell for sure based on the MAD. All right, so that could have been something you noticed. Which one is the least spread out? This one, right? Because it's 0. And notice like most spread out to least spread out, you can see that numerically, not just by pictures. Now, the standard deviation that's written next to it, we haven't talked about it officially yet, but we are going to today. Based on the values and how they compare to the MAD, would you say that the standard deviation is a measure of center or spread? So remember, center is a typical value, spread is how spread out it is. So standard deviation is a measure of spread. All right, and if you notice, like which one has the highest standard deviation? This one, right? And this one also has the highest MAD. So they kind of go together. They're a little bit different, but they both measure spread. So like over here where there's no spreading out whatsoever, they both 0. So that's good. What are some things that we wonder now? Anything? What did we wonder before? Why is that? And I'll shorten standard deviation 0 for the last one. Anything else we wonder? All right, wondering could be about anything. Yes, Ryan?
Why most of them have the maximum stage.
So why is the min and max the same? Maybe they're measuring the same things. Who knows? There's no title, so. All right, anything else we wonder? Anyone wondering what the heck standard deviation even is? Maybe that's something you wondered, or maybe you didn't even notice. But that might be something that you're wondering now. Also something you could have noticed that's in here that's interesting. It says the standard deviation is always greater than the MAD, except for in the last plot. That's something else cool that you could have noticed. So today is all about standard deviation. And so let me actually take you through the slides for that. You can see the goal for today. So the goal is to learn about standard deviation, which is another measure of variability. Usually, or in the past, I've actually taught kids how to calculate it by hand. It is quite a process. It takes like all day just to do one problem. Not all day, but maybe like 5 to 10 minutes. But in the real world, like, are we really spending 5 to 10 minutes working something out by hand? No. We use technology. So the learning target is to be able to describe standard deviation as a measure of variability, and then use technology to compute standard deviation. In the past, I've had it on tests where they actually have to calculate it by hand. You don't. You just have to know how to use whatever calculator you plan to use on the test. I'm recording right now. I'll link it in the slides just like I always do. So if you're absent, make sure you check the slides to see what you missed and get any notes done that you need to take. The practice will be a puzzle piece, and in Schoology, get 2 attempts. Make sure that we're trying on those because that's what your quiz will most likely look like, or unit test, I should say. And here's the upcoming assessments and deadlines. So we set a date for the Unit 1 test. It'll be Thursday next week, barring anything crazy that happens. Binder 1 check will be the day before. So all your Unit 1 stuff, anything I told you to take notes on, is going to be part of that. And I'll have a list in Schoology one of these days. I'll have it in advance so that you have your binder ready. And then anytime there's a unit test, that's also like the deadline for labor from that unit. So you can still turn in all of your Unit 1 stuff up until Friday, September 2nd, which is actually a day after the Unit 1 test, but I like that day better. So just keep that in mind. By the Unit 1 test, you should have all your Unit 1 stuff turned in. Otherwise, I don't have to accept it for that. Now, yesterday I did publish the scores for the Unit 1 quiz, so you may have saw that. No, just know, like, assessments, when there's only one assessment in there, it really takes a toll on your grade, whether it's good or really bad. So still stay on top of your stuff. If you want to retake that assessment, there is a folder in Schoology called retakes, and I'll show you where that is right now. All right, so in Schoology, we're on like the main page, and then if you scroll all the way down, you'll see this rainbow thing that says retake. And it gives you instructions too. So if you want to retake an assessment, you must complete all of the problems in the assignment for that specific assessment. So it's like a remediation assignment is what we call it. It's good practice, so that way when you come and retake it, you're not wasting your time and or my time, and that you actually get a good score. So if it's a worksheet, you'll upload a picture of it. If it's like a puzzle piece, you're going to score at least an 85% before I let you retake. It's not optional. Oh wait, no. This is optional. Like you don't have to do the remediation if you don't want to retake the quiz. All right, but if you want to retake the quiz, then you know you gotta do it. All right, so then there may be due dates on it, usually by the Unit 1 test. And if you click on it, we're in Unit 1 right now. There's only one quiz remediation, and then the retake will also be in Schoology, but I have a password for that. So I am limited on availability. Right now, my only tutoring days are Wednesdays after school, and sometimes I get pulled for meetings. So it's less of tutoring and more like kids coming into a retake. So if you're wanting to retake today after school, I'll be here. I have a virtual meeting, nothing like crazy that has to be like private or anything. But if you want to do your remediation assignment, it's pretty easy questions in my opinion. Do your remediation assignment, score an 85% or higher, come in today after school if you want and retake it, and then you're eligible. If Wednesdays don't work for you after school, I mean, I am sympathetic to you, but then that just means I might have to pull you from during class to take it. And that's like that's on you to like say, okay, I want to retake it during class. So just keep that in mind. I'm limited on availability, so that's why I would even let you retake it in class because I know assessments are important. But Wednesdays after school are the only times like that you can really come in. So any questions? And that includes today, if you're wanting to retake it and get it up today. Athletes, the first grade check is, I think, August 28th. So definitely want to be above a 60%, probably much higher, but that's the minimum. All right, so now on to today's lesson. And instead of doing all this random stuff they want us to do, we're going to kind of make it easy like we did the other day when we used technology. I'm going to show you the way that you are used to, and then I'm going to show you with a calculator that you can actually use on the test. So I'm going to have you guys, if you don't already have your Chromebook out, take it out. Go to this week's folder if you can. And find the Geogebra spreadsheet app. All right, so pull that up. It's in this week's folder. So we can have our data set 1, and I know the fire alarm kind of blocks it, so I'm going to type the actual data in the second one, like in A2. So what's my first data point for this first dot plot? Good, it is 1. So this one will be data set 1, and this one right here will be data set 2. All right, but class, what's the first data point for data set 1? And then, 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 just 10. It ends at 10. But yeah, thank you. So there's 1 dot on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I put all those numbers once because they each just have 1 dot. That's our data set 1. I'm also gonna type in data set 2. And earlier someone didn't know how like to make the columns wider. So if you want to look right now, just hover in between the column line where you get like this little thingy that pops up. And then if you just drag it, now you can see the title. All right, but now type in your data set 2 data. So what's my first data point for data set 2? And then, 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 and then. Good. So what you should notice is that there's 10 dots. So make sure you have 10 on your list. I did it 2 through 11. So that's 10. And anyone remember how we pulled up that little like statistics box? If you don't, maybe like press a few buttons. You guys can probably figure it out. But like last week when we pulled up the statistics box that showed us like a list of the mean, the Q1, the median, the Q3 without us really having to calculate it by hand. All right, well then press around. There's not many buttons, so just see what happens. Highlight your data or one of the data. Maybe try pressing a few buttons, see what pops up. If you can use like Instagram or TikTok, and you can figure out how to use a graphing calculator. All right, so what do we press? Oh, that's kind of cool. I didn't know you could do that, but I want the different one that has all of it. So let's try some other stuff. You press this one and then you press one variable analysis. And then do you guys remember what you pressed after that? Where is that? What does it look like? I know how to do it. I'm just seeing, I just want you guys to be like problem solvers because I'm not going to show you how to do it on like a test or anything. And this is how you can do it at home. What do I press next? Try it yourself. See what happens when you press buttons. Anyone? The longer this takes, the less time you have for your practice in class. Is your hand up? Let's see. I don't have my screen trying to bring me. Anyone find it? What is it? Yes. Good. It's actually a sigma, but yeah, it looks like an E. And when you click on it, first of all, you hover over it, it says show statistics. That box pops up. So let me do that again with my data because for some reason it didn't pop up the first time. All right, but then you hit this. And now you have for data set 1, a lot of things in here that are already solved for you. All right, anyone remember what the N represents? Okay, we'll skip that one. Anyone, well, we have like the mean, which we do use. This is a standard deviation, but it's of the population. And this one says that specifically they're using the other kind of standard deviation, which would be this one, the X. All right, so here's my standard deviation. For data set 1, it's 3.03-ish. Then there's some other stuff that you don't really need, but we do use like the minimum, the Q1, the median, the Q3, and the maximum. All right, so that if you want to use for your homework, you can. We don't use it for tests. I'll show you what we will use on tests. But now, oh, and also the N is your number of data points. So that's 10. All right, that was on one of our cool. So now do the same thing, find the standard deviation for data set 2, which you should hopefully have typed in, if not. It won't show it for you. Okay, try it again and make sure like the bar shows up. The bar chart. You guys try again, highlight it, press this thingy, the histogram, one variable analysis. should get something like this first, and then you click show statistics. And what's our standard deviation of data set 2? Yes? Question? Okay, what is it? 14.9. Good, so about 14.91. All right, that's a lot easier than finding standard deviation by hand, so I'll just show you the difference. So standard deviation is a long process. I'll just show you the standard deviation formula. All right, look at it. It's not hard, it's just very time consuming. But this is what we normally use for standard deviation, but we're not looking for the population standard deviation in the lesson right now. And then it equals the square root of sigma, which means sum of each value from the population minus the population mean squared and then divided by the size of the population. So it's all operations that you can do, but it's just not very fun to do by hand. And in the real life, we don't really do it by hand. Now looking at the standard deviations, which data set is more spread out? Data set 1 or data set 2? Good, data set 2 has more variability. And while you probably could have figured that out from looking at the data, like how spread out is data set 1 from each other, how do you go from 1 to 2? You add 1, how do you go from 2 to 3? Add 1. And data set 2, how do you go from 10 to 10? But then it jumps from 10 to 20, how do you get that? So it's more spread out. You probably could have seen it just from looking at the data. But for data sets that are really close to each other, the standard deviation value can tell you for sure. A higher standard deviation means that there's more variability, so it's more spread out. All right, so that's with something you've already used before. Feel free to use it for your practice. I'm also just going to show you on Desmos, because I did find out that you do get to use Desmos on the Illuminate app, which is where you'll be taking your Unit 1 tests. That's where you tested yesterday too. But here's how to do it on Desmos. So pull up Desmos, desmos.com, click on the graphing calculator. And say I want to put in data set 1. So I'm going to, in this cell, type in, like, maybe I'll change it to a letter. So like, maybe we'll call it data set A. Equals, and then put a bracket. It's kind of like a parenthesis, but boxy, find it. Put in a bracket, and then type in your data. So like for data set 1, it was 1, 2, 3. Make sure you put commas between your data points. 4, 5, 6, 7, 8, 9, 10. All right, now you have your data in there. In a different cell, you can type in, and since we're doing standard deviation, well, first let me show you with the keyboard. So press this little keyboard so that you can see this keypad. Then press functions. And there's a lot of like cool stuff that pops up. So like you can find the mean of data set A and see instantly that it's 5.5. You can find the median, minimum, maximum. Quartile is kind of like how we did in Google Sheets. All right, so type in like data set A, comma, whatever quartile you want to find. So if it's quartile 1, then you know the quartile 1 is 3. You can also type in the words and then it'll turn it into the function. So cool stuff. All right, you still need to know like the process. So that's why we always teach you the process. But now if you have to do like quick comparisons, you can see it on your test. Just know that you do have like 3 short answer questions on your test. And if it says to show work, then don't just say I used the calculator. All right, you have to actually show work if it asks you for that. And then if you look again, there's also for standard deviation. There's actually 2. There's one like just normal standard deviation. So let me get rid of these. So that there's normal standard deviation. And then there's one for standard deviation of a population. This one, only difference is a P there for population. And I noticed when people were doing their homework earlier, it may have wanted this one or it may have wanted that one. You just type in both. They're pretty close to each other anyway. And then click the answer that matches. But yeah, there's my standard deviation for data set A, same thing we got on the Geogebra sheet. And then if I put in for data set B, go ahead, you guys do that, same process we just did, but data set 2 data. All right, so then type in your data points. This is what they were, if I remember correctly. If I'm wrong, please tell me. All right, but I should have 10 data points. And then whatever I'm trying to find for that problem. So let's do standard deviation, this time of data set B. And same thing we got in the other one. But this one you can actually use on your test. I don't know if they disable some of these functions. I don't know why they would, but I will never make you do standard deviation by hand on this unit 1 test. Questions, comments, concerns? All right, on your note sheet, well, there's some questions and then we'll do the lesson synthesis questions. So these aren't printed, at least I don't think they are on your note sheet. So we're just going to answer them though, because they are super helpful. What does standard deviation measure, center, or spread? Does it measure a physical value or does it measure how spread out the values are? So that would be a measure of spread or variability. FYI. Measure of. Now, for this second question, and they did a bunch of different data sets in the activities, like whoever made this, we don't need to see that to understand. But it says, why is the standard deviation the same for this data set? 1, 2, 3, 4, 5. And for this data set, -2, -1, 0, 1, 2. Think about it, don't say it. Why is the standard deviation the same for these 2 data sets? All right. Any volunteers for why it's the same? Jalen? They both count up by 1. And if standard deviation measures spread and they're spread out evenly, then they should have the same standard deviation, right? So both go up by 1. Like -2, you add 1, you get -1. -1, you add 1, you get 0. Same for 1, 2, 3, 4, and 5. Now, why would the standard deviation be different for this data set and this one? Don't say it out loud, just look at it, think about it. All right, any volunteers? Why would it be different? Landon. Good, this one goes up by 2 each time, and it won't necessarily always be like a consistent going up by 2 each time, but it is for this one. And this one goes up by 1 each time. So we should expect them to be different. Which one would have a greater standard deviation? The first one or the second one? The first one, because it's more spread out between the numbers. When will the standard deviation be equal to 0? Good guess. If it's uniform, but not necessarily. If all the data points are the same, Amari? Good, so you both kind of said the same thing just there. So if all data points are the same, slash not spread out at all. If all data points are the same or not spread out at all. Have we seen an example of that? Yes, in our warm-up. So if I go back to that, which one would have a standard deviation of 0? This one, the one where all of the data values were on the 10. So that's the only time it would be 0. Otherwise, they might be, the standard deviation might be small, but there's usually one. What is your means? Okay, we didn't actually do that part, so let's get that part. And now let's do the cool down. So the cool down is always on a separate paper. I gave it to you Monday, pretty sure. That's what my other class told me. So unless you weren't here Monday, then you should hopefully have it in your binder. We didn't use it yet. We didn't use it for lesson 11, but we are for lesson 12. Yeah. Well, one of them we took notes on, the other one we didn't touch at all. Well, that's good. You should have it. Trust me, yes. So the other, yes. So the weekly folders, I think are the most fun. So you started that, yeah, there you go. Yes. Yeah, we're doing the cool down right now. So here's the image for the cool down. These questions are printed for you. We're on lesson 12. And we're doing the cool down. So think about it for yourself for a few minutes. If you finish early, feel free to start on your puzzle piece. So we are going to go over these. I feel like these are super helpful and important. So that's why they're usually on their own separate page with all the other lessons. So for number 1, it says the standard deviation of Christchurch temperature. So some city in New Zealand, it looks like. I think that's it. Nope, I didn't. Why is it not working? Okay, the standard deviation of Christchurch's temperature is 0 because the data is symmetric. True or false?
False.
And why do you think it's false? Because the data points are spread out. All right, what did we say it looks like when the standard deviation is 0? When they're all on the same answer, so something like that if it's a dot com. So false because the data is spread out. Someone earlier said because the data is not symmetric. Is the data symmetric? Is it a mirror image on both sides? Yes, so it is. It's still false, but it's because the data is spread out. What about number 2? The standard deviation of St. Louis's temperatures is equal to the standard deviation of Chicago's temperatures. So looking at this one and that one. I think I heard both answers. Anyone else care to chime in? So they're saying that they are equal. Are they the exact same shape? Yep, I would say they're the exact same shape. Do both number lines count up by the same amount? Yes, this one might be starting at -1, but they still go up by 1 on each number line, right? So the answer for number 2 should be true. Because they both go up by 1. Or I don't want to say both go up by 1. They have the same variability. They're the same exact shape. And number line, I guess you could say. Because the number lines both go up by 1. All right, the standard deviation of Chicago's temperatures is less than the standard deviation of London's temperatures. So these 2 dot plots, true or false? So it looks almost like they're exactly the same except for these 2 dots. We have one on the 5, one on the 8. Which one is more spread out? London, because this data point is farther from the rest of the data compared to the one that's on the 5. So this is true or false again? Sorry. True. Chicago's is lower spread out, lower standard deviation compared to London. So that one you actually didn't even have to put in your calculator because you could tell visually which one might have a higher standard deviation or not. Because it's how spread out it is. Questions, comments, concerns? All right, and there's the formal definition for standard deviation, just so you know, it's a measure of variability or spread calculated by a similar method to calculating MAD, but it's just a little bit different. So use them for different reasons. One thing I will cover for like the recording's sake, I guess I must have lost the question somewhere. This I think is printed on your note sheet, is it? Not the cool down, but the note sheet. I think I just missed it when I was going through the slides. So on the back of your note sheet, the one you picked up today says lesson synthesis. It has these questions. If you want to jot this down, I think it would help you to understand the difference between standard deviation, MAD, and IQR. All right, so you're probably wondering, like, why do we care? Why do we have all these different measures of spread? We use them in different instances, just like how sometimes we use the mean over the median based on how the data is shaped. Sometimes some of them are better to use. So for this one, we're saying that the standard deviation is based off of the mean. Because if you remember, in that formula, it does minus the mean at some point. Just like how in the mean absolute deviation, they also minus the mean. So both MAD and the standard deviation are based off of the mean. So if the data is symmetrical, you'll probably want to use those for measure of spread. You use IQR if the better measure of center is the median. All right, and this one already has the answer revealed, but hopefully you could tell me the answer without having to look at the answer. If I have a data set with a standard deviation of 5 and another with a standard deviation of 10, what does that tell you about the distribution of each data set? Which one has greater variability? The second one, because the standard deviation was higher than the first one. Right, so it's easier, I think, in my opinion, to compare numbers than it is to compare shapes, which was what we did yesterday. All right, so that gives you 12 minutes of class time. Do use it wisely to work on your puzzle piece and ask me questions, while we're here and before you go home and have to rely on your parents or someone else, the videos.